This question says the masses and radii of Earth and Moon are m1 r1 and m2 r2 respectively. Their centers are at a distance d apart. The minimum speed with which a particle of mass m should be projected from a point midway between the two centers so as to escape to infinity is. So at infinity we know that the potential energy is 0 and kinetic energy is 0. Let's say this is Earth and this is Moon. Now both are separated by a distance d and this mass is m1, radius is r1. This mass is m2 and radius is r2. At the center the distance from here is d by 2. This is distance from here is d by 2. I'll call this point as P. Now potential energy of the particle at the center is equal to, I can write minus gm1 by d by 2 minus gm2 by d by 2 into the mass of the particle. This is potential energy. So I need to find kinetic energy anyhow. Potential energy at infinity is 0. Similarly, kinetic energy at infinity is also 0 because we just need the velocity to be enough to escape into the outer space. So now, because the total energy at infinity is 0, total energy at point P should also be 0. In that case, the kinetic energy would be just enough for the object to escape the gravitational field of the system. So let's see. So I can say kinetic energy, that is potential energy, can be written as minus 2g by 2. We'll take it out into m1 plus m2 plus kinetic energy, we'll say half mve square. We'll say velocity ve is escape velocity should be equal to 0. So here we have m. This implies, I'll cancel m and m here. If I take this to RHS, I'll get ve square by 2 equal to 2g by d. It's not 2, it's d. 2g by d into m1 plus m2. So ve would be equal to 4g by d into m1 plus m2 under root. So I can take out 4, so I'll be left with 2 under root of g into m1 plus m2 by d. So the escape velocity, or the minimum speed with which the object has to be projected from point P so that it escapes the gravitational field of the system, would be 2 root g m1 plus m2 by d. That is option B. Hope you could follow this. Thank you very much.